Hello people, welcome back. So we got here question 8 from the Chemistry Higher Tier 2018 paper 1. So let's get down with this. Now, this question is about iron. Iron reacts with diluted hydrochloric acid to produce iron chloride solution and one other product. Name the other product. All right, so this is a pretty easy question. This is one of those questions that you need to know your general formula when reacting a metal with an acid, okay? So let's write that down. Gas. Okay, now this here is one of those formulas that you just need to remember. Okay, just how you memorize your times tables, this is something that you need to just memorize yourself and remember. Okay, so iron is going to be your metal, hydrochloric acid is going to be your acid, the salt produced is going to be iron chloride because we're using iron and we're using hydrochloric acid, so that will be your salt, and then whatever you got left is going to be your hydrogen gas. Now, it's very important. You can either write down the word or you can write down the formula, which is H2. If you write down H, you will get that wrong because H is just hydrogen. It is just the symbol for the element. H2 indicates that it is a diatomic molecule, which actually means that it is actually hydrogen gas. Okay, so let's write that down. Now, it's also very important that you do capital letters when writing them down. Okay, if you do a small caps H there, you will get no marks for that. All right, question 8.2 suggests how any unreacted ion can be separated from the mixture. Okay, so if you have any ion and you put into the hydrochloric acid, is gonna combine and make an iron chloride, which is a salt that will dissolve in the excess water because it's diluted hydrochloric acid. That means that it has been diluted with water, so there will also be water. So as soon as the iron chloride is formed, it's gonna dissolve in that water over there, in the water. Yeah. So once all the acid has reacted and you still have iron left over, you need to separate them. How would you separate them? Well, how do we separate a substance that doesn't dissolve in a liquid from the liquid that you put it in? And it's pretty simple. All you have to do is filtrate it. Okay, so you can just write down filtration, or you can use a magnet to remove the metal from the solid itself. Okay, there you go. You can use filtration and remove the unreactive iron, or you can use a magnet to remove the unreactive iron. Now let's go to the next question, and this is one of those juicy ones that makes people just curl up and quit. Magnesium reacts with iron chloride solution. 120 grams of magnesium reacts with excess iron chloride solution. The relative atomic mass of magnesium is 24, iron is 56. Calculate the mass of iron produced in milligrams. Okay, right. So for this question, we're gonna go back to using ICE. So the I stands for information. Okay, now what information do we have? First of all, we have iron chloride solution, and that will be your AQS, because it's telling you here this iron chloride, so that will be an AQS solution. And then you add magnesium. Magnesium is a metal, okay? So magnesium is going to be a solid. So you effectively adding magnesium to iron chloride, and then you end up with iron and magnesium chloride. Now the reason for that is because magnesium is more reactive than iron. So magnesium is going to displace the iron from the chlorine, and then it's going to take over to make from the chloride, and then it will make magnesium chloride, and the iron is left by itself. So that's the first thing we need to do. We need to understand what is actually going on. So once again, iron chloride, you add magnesium. Magnesium is more reactive than the iron. It's going to displace the iron to make magnesium chloride, leaving the iron all by itself. Now, this is a balanced equation given to you, and it's giving you the ratios. For 3 moles of that reacted with 2 moles of that, you're going to have 2 moles of this and 3 moles of that. So 0.20 grams of magnesium. Okay, so magnesium is 0.120 grams. Okay, there we go, of magnesium reacted with excess iron chloride. So this was in excess. There was a lot of that being given off. the relative atomic masses are given for you, and you calculate the mass of iron produced. So how much of this in grams was produced after the reaction happened. All right, so we got our information, so let's just write it down. Now, in conjunction with ice, I'm going to use the other thing that I use, and it's know what you have to find out what you need. Okay, so let's go for here. So when it comes to the products, so I'm going to do the arrow here so we know what we got in the products and what we got in the reactants. So in the products, the mass, now we got some relative atomic masses over here, and you need to calculate the mass of iron produced. So how can I calculate the mass of iron? Right, this is going to take us to the so we got our information, we know what we have here. Now we got the mass of that, we got the relative formula mass of magnesium, the relative formula mass of iron. So let's go for so that has been done. Converting units or changing units, we don't have to do any of that right now, so we're gonna skip that for now. Equation. So what equation can I use mass and relative formula mass? So the equation that we're looking at is moles. Okay, the mass of iron. So I could rearrange this equation, and I can go into the following. To calculate the mass, okay, I'm going to need moles times the MR. Now I know that the MR is 56, but I don't know what the moles are, so I can't continue with this side. Let's find out what we got here. Now in this one here, I do have the mass and I do have the MR. So let's go for moles equals the mass, which is 0.120 grams, over the MR, which is 24. So I'm just going to quickly slap that into my calculator. 1.020 divided by 24, and that gives us, we convert that from standard form, so 5.0 5 times 10 to the power of -3. So that's going to give us okay 0.05. That is our concentration. Okay, so now that I have the moles, okay, these are the moles of the magnesium being used, and you know that over here is giving us 3 to 2, so the ratio is 3 to 2. So what we're going to do now is that we're going to do 2 over 3 times 0.005, and that should be the moles of the iron. Okay, so in the calculator is giving us a standard form, but we know that if you do standard form, you can just change it into decimal by moving the decimal place to the left because it's negative. We're going to move it 3 times, and that's going to give us 0.00333 and so on. So this here must be the moles for that. So now all I have to do is do the 0.00333 times 56 0.18648 grams. Okay, and up to here you will get 4 marks because the answer must be in milligrams. You need to convert that into milligrams, which means that you're going to divide it, so you're going to multiply it by 1,000 times 1,000 is 186.48, and that could easily go rounded up to 5, and that can be rounded up to 187 milligrams. There we go. And that will be your final answer right there. I know it seems to be a little bit long-winded, but if you follow the simple steps, it's very, very easy. So first of all, you want to gather all your information, and that's what we did here in the top section. Conversion of units, that's what happened at the end, so you don't need to worry about that for now. The equation is this. Now remember that you're only gonna get equation sheets for physics, not for chemistry. So this is one of those equations that you just gotta memorize. You just gotta know it from by heart. Okay, so you got your equation, which is this here, and then you done your substitution. I substituted the values. I rearranged my equation, substitute the values, done our multiplications, got our results, and then all you did had to do the conversion of units at the end. Now this here may be a little bit complicated, but essentially what it's telling you is that you have the grams and you have the relative formula mass of magnesium, so you gotta calculate the moles. Okay, now over here what this is telling us is that those are the ratios in which you find them. Okay, if that was a 4, if that was a 1 and that was a 2, you gotta multiply it by 2. If that was I don't know, half of that, that means that that number would have been half for this one over here. But again, the only way that you want to get through all of these questions is by practicing those exam questions. So don't be shy, get those past papers, download those past papers. I'll put in the link in the description from where you get them, when you can get them with the mark schemes as well. Have a go at them, correct them yourself, and if you still are stuck, you can come and have a look at the video and see how I break down the answer in order for you to understand it a little bit better. Okay, so let's move on to question 8.4, and if you do have any questions, please write those down in the comments, and then I can get back to you as soon as I can. Okay, so let's go over here with question 8.4. Explain which species is reduced in the reaction between magnesium and iron chloride. Okay, now this is very, very easy. Okay, now remember that there is two situations in which you can reduce. Okay, if you're talking about oxygen, okay, if you're talking about oxygen, let's write this down. If you're talking about oxygen, when you're talking about oxygen, oxidation is adding oxygen and reduction is removing oxygen. But in this case, there is nothing about oxygen in there. So they must be talking about the other type of oxidation and reduction, and that is when we're talking about electrons, okay? And when we're talking about electrons, we can do oil rig. Now, in this case, we are talking about this oxidation and reduction, and that is because there is nothing to do with oxygen up here, okay? So explain which species is reduced in the reaction between magnesium and iron chloride. Right, so let's get this done. At the moment, okay, magnesium has no charge, because magnesium is just the metal magnesium, okay? It has no charge. Atoms have no charge. So in this case here, we know that the chlorine and the iron have a charge, because when you have a metal and a non-metal joined together, that is going to be an ionic bonding. And in ionic bonding, the metal loses electrons and becomes positive, and the chlorine gains electrons and becomes negative. So overall, we know that this is negative, and then this side here is positive, and they join together to become iron chloride. Okay. Now in the other side, now we see that, sorry, before we move on, this here, I was just going to emphasize it. This is a cation. This one is an anion. And this one here, okay, and I'm going to do this in a different color. This is just an atom, okay? This is an atom, because it doesn't have a charge. This one is positive, has to be a cation. That one is negative, has to be an anion. And in the other side of the equation, we can see now the iron used to be an ion, but now it has turned into an atom because it's all by itself, so it no longer has a charge. Now magnesium used to be an atom, but now because magnesium has joined in, it has become an ion. Now it has a charge of plus, and now it's turned into a cation, okay? This one is still negative, the anion That one is negative here and is also negative over here, so that didn't change. Now when you're talking about the what's it called, the explain which species has been reduced, you're talking about something that has changed, and saying your answer you should include the half equation for this reduction. Okay, so the half equation only shows you when something has gained electrons or when something has lost electrons. Okay, so by looking at oil rig, magnesium used to be an atom and then it became positive, which means that magnesium lost electrons, it lost something negative, and now it has become positive. Okay, iron used to be positive and now is back to normal, which means it must have gained the electrons that it lost back. Okay, so what happened here? Magnesium lost electrons and became positive, so oxidation is lost. Magnesium must have been oxidized because it lost electrons, which means that iron used to be positive because it lost electrons. Now it got them back and went back to being normal iron. So reduction is gain of electrons. So who has been reduced? And that will be the iron. Iron was reduced because it gained its electrons back to go back to being a normal atom. It used to be an ion before the reaction started, and after it turned into an atom. So it gained the electrons back, which means that it has been reduced. Iron has been reduced. Okay, so this is a 3-mark question. So the first thing we gotta write down is to identify which species has been reduced. Okay, so we're gonna say the iron 3 has been reduced. And how do we know it's iron 3? Well, because if you have iron and chlorine chloride, that means that each one of those ions and each one of those chlorine has a value of -1. So you have -1, -1, -1 to make a total of -3. And that means that because we only have one iron, that iron must be iron 3. Because iron 3 will have a charge of +3, which means that the charges cancel each other out and they make a stable compound. That will be 1 mark. You identify what has been reduced. Now you want to write down why. Okay, there we go. That's 2 marks. But the last mark says that you should show your answer with a half equation. Okay, so we need to show the half equation for it. So how do we do that? Essentially, this is what you got. You used to have iron and it was a 3+ iron. Okay, then it gained, how many electrons did it gain? It gained 3 electrons and it turned into the normal iron. It went from being an iron ion into normal ion. So this was the ion, okay, with a charge. It gained its 3 electrons and it turned into an atom. Okay, it went back into being an atom. Now in some other cases you may see this represented differently. You might just say what's it called? You could say that an iron is the same as having 1 iron ion plus 3 electrons, or you can just represent it like that. Okay, I find this way makes more sense because it can actually describe what we got. I believe in some cases it may just be represented slightly different, but as long as we understand the gist of it, this should be okay. Okay, so again, we need to practice a little bit more in those reductions to find out which species has been oxidized, which species has been reduced. Now in this case, this is just extra information. So it says what if they ask you what species had been oxidized, then that would have been magnesium, because magnesium would have lost its electrons. It used to be a normal atom, then it lost its electrons and it became an ion in order to be able to do the ionic bonding. So the half equation for that would have been magnesium used to be an atom, then it lost 3 electrons. It lost 2 electrons. Well, this is not balanced, that's probably why. But magnesium would have lost 2 electrons. It lost 2 electrons and it turned into magnesium 2 plus, okay? And that would have been the opposite of that. That's the oxidation of magnesium. This is the reduction of iron, okay? Right, so that is it. That is question 8.4. That is the end of the paper 1 chemistry 2018 higher tier. So if you find this useful, please subscribe to the channel and give the video a like. It helps the algorithm to just make it pop as soon as you write down past papers. That will help me and that will help you. It just keeps me motivated to doing these videos because I just enjoy doing it, okay? And if I know that you're actually benefiting from it, then I'm more likely to get some time and produce a few more of these. Now, I will be making the rest of the chemistry ones for 2019, 2020, and so on, all the way to 2025 is possible. And once I've done with that, I'm gonna start doing some of the biology and physics as well, okay? So there you have it, guys. That is the end of the video. That's the end of this paper 1. So I hope you enjoy it. Hope you find this useful, and like and subscribe. Right, so there you have it. A quick time revision. Like and subscribe, and I'll see you next time.